Hey, this is Joe from EfiWires, and in this video I'm going to walk you through the process of getting registered for the harness design beta release that is currently live, and we'll also walk you through the basics of how to use it. So if you're not registered yet, the first thing to do is go over to EfiWires.com and just read through the page here to learn a little bit about what the Harness Design Studio does. And then you can request early access by clicking this button or just sending an email directly to support@efiwires.com. This initial beta release of the software is by invitation only, so you will need to go through this process to get a password before you can even register. But once you have that password and register, then you can log in and use the fully featured beta version. There's no cost to do so. All I need from you is when you send the email to tell me a little bit about how you plan on using it, like what types of wire harnesses do you build, what's your skill level, are you a professional, are you a DIYer. I'm really looking for people across the entire spectrum of experience level to get feedback on this product. Once I provide you the password for joining the early access program, you can come back to the website and click on the Launch Studio button, which will take you to the login screen, which also has the registration button on it. So your first time in, you'll have to click the registration button, and then this brings up the form where you put in the password that I sent you, and you read and accept the beta agreement. And once you do both of those, you'll be able to click this button to go ahead and get registered, and then you'll be able to log into the application. Once you're registered and logged in, you'll be taken to the dashboard. This is a snapshot view of important things that are going on in the system in your account. In the upper left-hand corner, you'll see various announcements from the system. In this case, it's just the announcement that the beta release is going on. The next one over is where you can purchase a new project. And this is because this Harness Design Studio is not going to be a subscription-based model. It's going to be a project-based model. At least the early releases will be that way. So there will be no recurring fees. You'll have one free project when you register, and it'll be called the Starter Project, which you can see down here. This will be a fully featured project that you can use however you want. You can use it to test and get familiar with the system as much as you want. If you decide you want a second or third or fourth project, at that point, you'll have to buy those projects. And the beta pricing is $99.99, so $100. It's a one-time payment that you will own that project for life. And each project is meant to be either a vehicle or a harness if you're doing production harnesses. But again, there will be no recurring fee for those. It's a one-time payment. Over here is a list of featured videos where you'll be able to get training on the product. This video I'm creating right now will show up here when it's done. I will be adding more in-depth videos explaining how to use the various features of the Design Studio as time goes on. And down here is just a little tool that I wrote that I found handy for figuring out the total CMA for a wire bundle. If you're trying to stuff a bunch of wires into a splice or terminal, you can put in how many of each gauge wires you have, and it will show you the overall CMA for that bundle, and it will also give you a visual indication of how close it is to a given American wire gauge size. I found that handy when I'm creating splices and stuff, so that's there for your use. Now let's get started on how to actually use the product. I'm really trying to keep this video short, so I'm going to touch on a lot of topics without going in depth into them, but I'm going to at least show you the high-level view of some of the things that I think are important so you understand what's happening as I do this demo. So I'm going to start with the profiles down here. Profiles are basically rule sets that tell the system how you want to build your harness. There are a couple predefined ones in the system. I'm going to just pick the Holley EFI one, and I'm going to go straight to the wires so I can show you that the Holley EFI profile has all of the wire size and color combinations for each given circuit defined the way that Holley does for their harnesses. So if you're trying to build a Holley harness or replicate one, you use this rule set, and when the wires get added to the system, they will automatically have these colors, types, and lengths as you add them. Libraries are component libraries that are all the components, all the devices, connectors, sensors, so on, that you can choose from when you're building a harness. The system is driven by selecting components from the library which have their pinouts defined. For example, this LS coil you can see has the GT150 connector defined, the part number. It has the pinouts here for the 4 pins, where they go, what their circuits are, and that enables the system to automatically build most of the design as you're going. When we get to the projects here, you will see an empty project. You'll see the starter project. You won't see the empty project. You'll see the starter project when you first log in. So if you open that project, the first thing you need to do is select one of the profiles. This is a required field. I'm going to use the Holley EFI for the duration of this demo. You can specify the vehicle, year, make, model, and the owner's name if you want. That's optional. I'm just going to save it with the Holley EFI profile, and then we'll get started on actually building this harness. When you're ready to start designing a new harness, you will typically start at the Devices tab, and it makes the most sense to start by adding control modules or whatever has the most circuits defined in it. So in this case, I'm going to choose the Holley HP ECU and select that. And once I select that, when this is spinning, what it's doing in the background is creating all of the default circuits and adding connectors and wires and so on for that ECU. We can see here it created the J1A, J1B, and the power connections. It created a bunch of wires for all the ones that are set to be created automatically by default. You can later come in here and assign circuits to the other pins as you need. But for now, I'm just going to go with the defaults, and then I'm going to move on to the fuel injectors. You can add one fuel injector at a time. I'm going to use a shortcut button here where I can add multiple fuel injectors. I'm going to use a generic EV6 injector, and I'm going to do 8 of them. And again, this is doing the same thing that it did with the ECU. It's creating all 8 of those fuel injectors in the background, and it's wiring them up to the ECU. If we just pick one, for example, we can see that the fuel injector power is going to a splice that it created. And then the signal is going to J1B pin 26, which is fuel injector 2 signal. Do the same thing for ignition coils. I'm also going to use a shortcut here. I'm going to add 8 LS3 coils. It'll do the same thing. It'll add them in the background, wire them up, and you'll be good to go once this finishes. Takes a little bit more time because there's more wires and more circuits that it's building in the background. Now let's add a couple sensors to this project. Let's do the intake air temp sensor. So when you're adding a sensor, you can filter by type of sensor. So I'm going to limit these to air temp sensors, and I'm just going to choose the Rife sensor that has the Delphi connector. And I'm going to go ahead and give it a label of IAT because that's the circuit that I'm going to want it to use. I can also add other types of sensors. For example, if we do wideband, that'll filter down to just the widebands that are in the system. I'll go ahead and add an NTK sensor. If we look at the connections like we did with the fuel injector, we'll see that It's choosing the right wires and wiring them up to the right places based on the Holley profile. Similarly, we can add throttle devices. So if this is a mechanical throttle project, we can add a TPS sensor. Just by clicking that, we can add the idle air control valve. And so on. At this point, I should point out that the libraries are loaded with some devices right now, but there's a high likelihood that the devices that you want to use will not be in the library. So you have the ability to create your own device and define its pinout, and that will be visible only to you, but you can use it in any of your projects, not just the one that you're working on at the moment. So another thing that I'm looking for in this beta release is for users to tell me what items they think I should add to the system library so that more and more things will be available without you having to create them on your own. Now that we've added a bunch of devices to this project, let's go down the line here and see what the system added for us automatically in the background as we were doing that. We'll start with the connectors, and we'll see that it added a coil connector for each of the 8 coils, numbered appropriately. It's got the correct active series and part number and the number of cavities that each of those connectors has. It did the IAT sensor, a connector for the sensor that we chose. It did the correct EV6 connectors for the injectors. It did the correct AMP super seal connectors for the Holley, the O2 connector, the main power connector, and the throttle position connector. And we don't specify any boots or back shells, so I'll skip those. You can see that it also lists every terminal that it created for each wire that was added. It did automatically add splices where needed and resize them as wires were added to them as needed. So for example, if we look at the coil signal ground, there's a schematic in here that shows the splice in the middle, and it shows that it's being fed by the coil signal ground in J1B pin 14, and that splice fans out to the second position in all 8 of the coil connectors. And as the system was adding more and more coils to this splice, it will resize that splice as it needs to as it goes. Here's a list of the wires in the system. Again, these are all chosen based on the Holley profile. They're all set to be 10 feet long by default. You can change that wire by wire, or you can change that in the profile if you want. You can see that they're all TXL, and depending on what circuit they're on, they may be 20 gauge or 18 gauge as needed. If we move on to the Circuits tab, you can see a list of all the circuits that have been added to the project, along with whether they're in use, meaning there's a wire on them, and whether or not they're fully terminated. One handy feature here is you can use this filter to just show you the circuits that still need termination, and that will allow you to go into each of those circuits and finish wiring them up so the project is finished. Moving on to the bill of materials, this is broken out into 3 parts, but it gives you a list of the quantity and part number for everything that you've added to this project. It's got the connector parts in one tab, the devices in a separate tab, and then the wires in a 3rd tab. The cut list is a list of all the wires of each length. So for example, the project calls for 8 black TXL wires, 18 gauge, that are 120 inches long. This will be for automatically calculated and adjusted as you make changes to the project as you go. And finally, we have the build sheets. So every connector in the project will have a build sheet that you can either display on the screen, or you can print if you want to build the harness off paper. And the build sheets show you every pin in the connector, which terminal it uses, which wire goes to it, where does it go, which terminal is on the other end of the wire, how long the wire is, and what's the function of that wire. And if it's a wire that goes to a splice, there will also be the splice fan out, so you can see every other wire that has to go into the splice on the destination end. So for example, if we look at the J1B connector, we can see the fan out for the coil signal grounds goes from splice 2 to all 8 coils. And again, you have this for every connector in the project. And the last thing I want to show you is for the project that you've been working on. There's a button here. If you go back to projects, to your starter project in the info tab, there's a button here that says reset project. And what this does is it wipes out this project completely. So it makes it easy for you to go into a project, play around with it, add a bunch of stuff, experiment. You can come back here and you can easily just wipe it out and get right back to an empty blank project so you can try something else. You just, to confirm it, you have to type in the name of the project exactly as it's shown here, because this is an irreversible process. When you reset the project, it's gone. It's back to blank. So don't reset a project if you want to keep it, but it's handy if you want to do some experimentation. Well, that's it for my demo. I hope that was helpful. If you have any questions or comments or any feedback whatsoever, send an email to support@efiwires.com and I'll get back to you. And I'm looking forward to hearing from everybody, because I really think this product can help the wire harness design community at large. So good luck.